exponential functions.
Welcome back to my YouTube channel.
Welcome back to my YouTube channel. The parent function is f of x equals b to the x. Okay, that is our parent function. Now, for the most part this year, we've been graphing the parent function, and then we've been transforming it. We've moved it left and right. We've moved it up and down. We've stretched it. We've compressed it. We've reflected it. I don't love transforming functions when it comes to exponentials for some reason. I find that students can graph these best if we just go back to the old plug it in, plot the points, connect the dots. So that being because your base changes. Sometimes it's a 2, sometimes it's a 3, sometimes it's a 5/8. They're going to give you ugly fractions today. And so rather than figuring out what that base does to every single graph, we're just going to treat them as individuals. So we're going to go and we are going to use, whoop, let me skip right over 1. We're going to use 5 points. It's going to ask you to graph 5 points. As I do a couple of these, I hope, actually this might be the only one that we can see. As you begin graphing more and more of these, you'll start to see a pattern with your negatives and your positives.
They're, I remember this.
Ah, yay, they're what?
Inverse or...
They are.
Yeah.
That's exactly what they are. They're inverses of each other. No, that's perfect. So grab your calculator, and we're going to do 3 raised to all of those. So you don't need to wait for me. You can be faster than me probably, unless you're doing it in your home. Yeah, you're going to want your calculator. That'll be a good idea. So 3 raised to the -2. Don't round a decimal. Don't do it. Do you remember how to change from a decimal to a fraction? Yeah, math, enter, enter. You'll have to use the point plotter inside Alex. So not all of these are going to be pretty points. Because what was 3 raised to the -2? What'd you guys get?
Got it.
1/9. Yeah, 1/9. 3 raised to the -1 is 1/3. 3 raised to the 0. What? Anything raised to the 0 power is... Is 1. Anything raised to the 0 power is 1.
Explains so fast.
What about negative numbers?
Anything raised to the 0 power is 1. Yeah.
Anything raised to 0.
Anything raised to the 0 power is 1. 3 to the first is 3. 3 to the second is 9. Yes,
I
ma'am.
think that means that the exponential function on the calculators is a little broken. -3 raised to the 0.
Did you put -3 in parentheses? Then it's not broken.
I don't know.
Operator error, darn it. Yeah, make sure you put it in parentheses if you want to include the negative. All right, so plot those points. Oh man, -2 1/9 is going to be pretty darn close to right here, right? -1 1/3, 0 1, 1 3, and 2 9. Alex has that nifty connect the dot tool, right? But I've just got to be careful as I draw this. Now my question for you is, what's happening over here on this left-hand side? What direction is it going?
Across the x-axis.
Is it going to cross the x-axis?
No,
That's my question.
Go along.
It's going to go along. It's going to get closer and closer because, let's see, 3 raised to the 1/3 would be 1/27. To the 4th, 1/81. Right? It's going to get closer and closer and closer to 0, but it's never going to cross it. Now, if you look at those directions, I should have just graphed really big points because I missed all of them. Really big points. There we go. I didn't miss any of them. I went through all of them. Look at that. The directions up there say graph each function and its asymptote. An asymptote is, I know, a line that your function approaches as it heads toward infinity, okay? So you'll have to, not on all of them, but on several, plot the asymptote.
I think we got it.
For the most part, I think you do. Let's, what's different about this one?
We have 1/4.
Does the 1/4 bother you?
No.
Okay, what about this one?
Wait. No.
So you're saying I have my calculator, I'm good. I believe you. Okay, I do. I totally believe you.
1/4 times 2 raised to 7.
So you can type it in, which one were you doing? This one?
No.
So as long as you type the whole thing in, it will do the order of operations for you. If you're not going to, do 2 raised to the power, hit enter, and then times it by 1/4, if that was your question. This last part right here, though, it gives me the graph. And this is the only place that I really like translations. If I have this function right here, and it's saying, hey, the parent function is up here. By the way, why does it start high and have the tail on the right? What did that?
Started.
That fraction right there. Yeah, that fraction right there. So let me go back up here to the top. What do we know plus k does? Think about all of your other functions we've been graphing. Okay, that goes up and down. When it's inside with the h, what does it do? It goes left and right. What do we know about that left and right because of that sign right there? It's the opposite direction. So right here it says, here's the parent function, 1/3 raised to the x. And it wants us to just translate it. So it's not asking us to plot more points. It's asking us to grab that function and drag it and put it where it goes. So what does the -2 do?
Drag it down.
We're going to go down 2. What does the -1 do?
Or you can go right one.
So we're going to go down 2, right 1. I'm going to take just a couple of points. Down 2, right 1, maybe this one. Down 2, right 1. To just kind of give me an idea. Now you won't have to plot points. I needed to on my paper. In Alex, you're just going to use the grab it tool and drag it to where it needs to be. Does that sound lovely? All right. What is the domain of my function?
I hate those.
I know, that's why we're working on it, because we do. We hate it. What's the domain? How far left is that arrow going to go?
Forever.
Forever and ever and ever. And I know that arrow is going up, but is it also going right? So how far right over infinity is it going to go? Forever. So left forever to right forever, what is my domain?
Forever.
Infinity, infinity.
Infinity to infinity. All right. What is my range? So we just talked about the x values. What is our range? What's the minimum y value we're seeing here? Where did we put that asymptote?
One.
We didn't put it on 1. We put it on the x-axis, which is y equals 0. So are there any values below 0? No.
It's never going to cross.
It's never going to cross, so can it equal 0? If it's
Yeah.
never going to cross, it's never going to cross, it can't equal 0. So we go from 0 to infinity. Okay, I love that you guys are like, we remember how to do this. We don't need those 2 graphs.